Our first deep dive here is into Martin Kleppmann's Designing Data-Intensive Applications, or DDIA. It's widely considered the guide to data systems.
Yeah, it's become a modern classic, essential reading.
It really deconstructs the architecture of things like databases, caches, message queues, focusing on those fundamental trade-offs you always face around reliability, scalability, and maintainability.
And when we connect this to the bigger picture, AI and ML systems are, well, they're the quintessential data-intensive applications, aren't they?
Absolutely. The scale is enormous.
They process these huge data sets for training. They need to access low-latency feature stores for real-time inference. They manage complex data flow through MLOps, pipelines, machine learning operations.
Right.
DDIA gives you the architectural vocabulary, the mental models to design these systems robustly. Think about concepts like replication and partitioning for scaling training data across many machines, or understanding different consistency models, how data updates are viewed across a distributed system when you're tracking ML experiments reliably.
But I hear this prevalent myth, oh, this book is kind of obsolete now because of serverless platforms and managed data services. The argument is, the cloud handles all these complexities for you. How would you respond to that?
That's a really dangerous oversimplification. These services, they don't abstract away the fundamental principles and the trade-offs of distributed data systems.
They just give you different building blocks.
Exactly. A managed database still has a consistency model, like eventual consistency, where data might take some time to propagate everywhere. An engineer flying blind won't understand why their supposedly infinitely scalable database suddenly grinds to a halt.
Yeah.
Maybe it's because of a hot partition, where too much data or too many requests are hitting a single segment of that distributed database. DDIA teaches the timeless principles that govern all these tools, managed or not. It empowers you to be an intelligent architect, not just a consumer of services.
So how would you apply it?
Okay, imagine designing a real-time feature store for an ML model. You might prompt an AI for architecture ideas, Redis, Cassandra, maybe Postgres. Fine.
Yeah.
But using DDIA's mental models, you evaluate them not just as brand names, but as implementations of underlying principles. Redis offers great low latency, okay? But what are its trade-offs for durability if a server crashes? What about consistency? Cassandra gives you high availability, fantastic, but is eventual consistency acceptable for your critical features? The AI generates the what, the options, but DDIA provides the why and the framework for choosing.
Reading DDIA really accelerates your transition then, from maybe a back-end developer to a true systems architect.
I think so.
In an AI-driven world, this means being able to design planet-scale, real-time data infrastructure, not just, training a model in a Jupyter notebook somewhere.
Right, moving beyond the lab.
This expertise is immensely valuable and incredibly difficult to automate. An AI can generate components, sure, but it cannot perform that holistic, trade-off-driven reasoning required to design a complex, distributed system from the ground up.
That's the human architect's role.